So here we go, chapter 8, exercise set. The first one actually is super easy. That's nice. They give us this whole long explanation that we really don't even need. So I'm just going to skip all that. Here's a part that is needed for production. It's a widget. It costs 48 cents. And each unit requires 4 widgets. So what would be the standard cost per unit for widgets? How do we figure that out?
48 times 4.
48 times 4. That's exactly it, Zay. 48 cents times 4. So the standard cost for widgets would be $1.92. So each unit that we're making is going to have $1.92 of materials costs for widgets, whatever widgets are. I'm not even sure. It's some sort of a mechanical thing, but doesn't really matter. So that's all we had to do on number 1. That was pretty easy. Let's go ahead and move on. Okay, this one's named after you, Renee. It says, Renee is the operations manager, and the company makes spice chests out of wood. They tell us that the first employee has to select and mill the wood, and this takes 1 hour. Okay. The next employee has to cut the wood. That takes 30 minutes. The next employee assembles and sands the chests. That takes 2 hours. And then it goes to the finishing department. It takes 1.5 hours for them to finish it. So they have to put on some kind of a stain or lacquer. Did we do this one? I think we did walk through this one, didn't we? Okay. It was sounding really familiar. So yes, we did this in class, but let's go ahead and do it again. So that's 5 hours, right? If we add up 1 hour plus 1/2 hour plus 2 hours plus 1.5 hours, we get 5 hours. And then we multiply by the labor rate of $17.50, and we get, I think it was $87.50, right? Okay, so our answer is 5 hours and $87.50 is the cost, the labor cost per unit. Okay. Great, so that one wasn't so bad either. All right, this one is a little different. All right, so help me solve this one. Fiona cleans offices. She's allowed 5 seconds per square foot. She cleans building A, which is 3,000 square feet, and building B, which is 2,640. Okay. Question is, will she be able to finish both buildings in an 8-hour shift? And will she have time for a break? How do we solve this?
Take the 5 seconds and multiply by the amount of square feet to see how long it would take.
Okay, let's try that. So it's 3,000 square feet for one building, 2,460 for the other. So together, 5,460 square feet, right? Times 5 seconds. So it's going to take 27,300 seconds. So is that less than an 8-hour shift or more?
1. That's all out.
How can we figure it out?
Divided by 60.
Okay, we divide it by 60. Now we know it's 455 minutes. Divide by 60 again. Okay. Now we know it's 7.58 hours. That answers our question. So yes, she will finish within 8 hours. And there is a little bit of a buffer there. So yes, she will have time for a break. Okay, so we added the square footage together, multiplied by 5 to get the total number of seconds. Then we converted that into hours by dividing by 60 and dividing by 60 again. And we saw it was less than 8 hours, right? Okay, that one wasn't so bad. And this one's not too bad either. We're going to make a cost card. You might remember seeing that in the PowerPoint on Tuesday. So this is going to give us our direct material costs for 1 unit of product, our direct labor costs, our manufacturing overhead costs, and then we can add it all up to get our total costs per unit. Now, this particular product uses 2 types of material, 2 types of labor, and then includes both some variable and some fixed overhead. Let's take a look at the data. We're making, by the way, a glove box switch, and I have no idea what that is. But for 1 switch, it takes 16 feet of plastic coated copper wire. Okay, so we're going to go ahead and put that over here. Plastic coated copper wire, 16 feet. And it takes a half a pound of plastic material. So under plastic material, we'll put half. Okay. Then we can see the plastic material costs $20 per pound. So we'll put that under the cost per unit of materials. That's a little confusing because it says standard cost per unit. So I think they mean unit of materials in this case, not unit of product. And the wire costs $2.50 per foot. We'll put that here. Okay, everybody following so far? So that means if we have 16 feet of copper wire at $2.50 a foot, that's $40 of copper wire per unit of product. And half a pound of plastic material at $20 a pound, that would be $10 of plastic per unit. Okay. Any questions so far? Then we go on to labor. It says assembly labor takes 3.5 hours per unit, and those workers make $27 an hour. Finishing takes 2 hours per unit, and they make $29 per hour. Okay. So 3.5 times 27 comes out to $94.50. 2 times 29 is $58. Now we see our labor costs. And then we can go on to overhead. So it says the variable overhead rate, oh, it does say overhead is applied using labor hours. Okay, and the rate is $14.90 for variable per labor hour. And the fixed overhead rate is $15.60 per labor hour. Now, if you remember, it sometimes gets tricky when we're working with fixed overhead and trying to do it per unit, but let's not worry about it. We'll just work with the data they gave us, and we'll just multiply it by the number of hours, and that'll be the right answer. So the question is, since the overhead, both variable and fixed, is based on direct labor hours, how many direct labor hours are there? 5.5. Exactly right. Because we have to consider all of the direct labor hours, not just from one department, right? So we have 3.5 direct labor hours here, plus 2 here. So that's 5.5, and we use that same number for both the variable and the fixed calculation. Make sense? Okay, then we can multiply. So our variable comes out to 81.95 per unit, and fixed comes out to 85.80. Then we can add up all of these costs to get our total cost per unit. So if I did that right, we have $370.25 is our standard cost for each unit of product. And let's see. Okay, perfect. It came out right. So whatever a love box switch is, it's pretty expensive. That's the cost, so the price would be even higher. Any questions on this exercise? All right, good. Let's move on to number 5. Now this one gets a little more challenging. Here we're going to start using these tables that I mentioned to you on Tuesday. Okay, these tables like this, these are really useful for these kind of formulas, right? Remember we took a look at these formulas like actual quantity times actual price minus actual quantity times standard price. So that, you know, these were your price or rate variance formulas. These were your quantity. Oh, I'm sorry, actually the way it's divided up. These are rate and price. These are quantity variance, and then these are total variance. So when we have an exercise or problem like that, it's useful to use these tables, and I'll walk you through how we do that. In fact, we're going to do this many times today. All right, let's go ahead and see what's going on here. They give us some data in this table. They tell us for each ladder, for each unit, which is a ladder, it takes, and this is the standard, 3 pounds of material, the standard price for the material, and then we just multiply, we get the standard cost for materials. They tell us standard amount of labor in hours, the standard rate for the labor, multiply, get your standard labor cost. Okay. They also tell us that they made 3,000 ladders in July. They used 8,800 pounds of material. They tell us they bought 15,500 pounds of material. Remember that the amount you purchase is not always the amount that you use. So there are some exercises and problems where you need the purchased amount to figure out how much was paid for the materials, but then you have to remember they didn't use all of that. They also tell us there was a $250 unfavorable direct materials price variance. All right, it's a lot of information. The first question is, how much did they pay for the 8,800 pounds? And they didn't tell us that, so we're going to have to figure it out. So 8,800 pounds we know was unfavorable because by $250 because there was a direct materials price variance. So they paid $250 more than the standard price. So if we can figure out what was the standard price or cost, then we can add $250 and we'll get the actual cost.
Would you just multiply the standard price per pound with the 8,800 pound material?
Yeah, I think that'll work. $4.50 was the standard price per pound. And they used 8,800 pounds. That's $39,600. That would have been the standard cost. Now, since they had an unfavorable price variance, that means they paid more than that, right? $250 more. So if we add the 250, that gets us to $39,850. Let me double check that. Okay, and that is right. So that's our answer, $39,850. That one wasn't super hard. Some of the questions I find so hard and confusing that it's just easier to use one of these tables to solve it. Okay, and we're going to see some examples like that. Although this next one isn't too hard, we're going to use the table anyways. What is the direct materials quantity variance? Okay, so to figure out a quantity variance, these three formulas here are for direct materials. Let's make this bigger. Okay. So these three relate to direct materials. These three are for labor. These three are for overhead, right? So on this one slide, we can find really all of the formulas we need. And it's asking for direct materials, I think it was quantity variance, right? Quantity variance. Okay. So the first one was price variance. That's not the formula we need. The next one is quantity variance. That's what we need. And we see if you do the long form version, you take actual quantity times standard price minus standard quantity times standard price. I'm going to go ahead and put that in the table. Actual quantity times actual price, or no, standard price minus standard quantity times standard price. Okay, I'm just abbreviating this information here. And by the way, there's also on the next slide, the simplified version of these formulas. I actually find it easier to use the long form version in most cases. So even though it takes a little bit longer, I think it makes more sense. So that's what we're going to do. Okay, so to get this answer, put in the formula. Now we just fill in the information. We need our actual quantity. So actual quantity was 8,800 pounds of material. That's how much they used, right? So if they used that, we know that's actual. And then the standard price is that $4.50 per pound. You see the screen okay, Brandon? Yeah. So standard price, I'm going to put in the 450. And notice that goes on both sides with this formula. Then what we need is standard quantity. Okay, let's figure that one out. Since they made 3,000 ladders, what would be the standard quantity of material they would use? 9,000, is that true? Yeah, exactly. So up here it says 3 pounds per ladder is the standard. So times 3,000 ladders, that would be 9,000 pounds of material. Okay, everybody okay so far? Any questions? All right. Now that we have that plugged in, what we're going to do is multiply on both sides. So we take 8,800 actual pounds times the standard rate. And on the right side, we take the 9,000 standard pounds times the standard rate, 40,500. Okay. And the last step here is we're going to subtract. So you take the left side, subtract the right side. And we get negative $900. Okay. What that tells us is the cost based on the actual quantity that we used was $900 less than the standard cost based on that quantity.
You said negative or favorable, right?
Yes, negative would be favorable because our costs were lower than the standard. So we're going to put up here as the answer, $900 favorable. All right. Little time consuming, but if you go step by step, then it kind of works out right as long as you put in the right numbers. So let's confirm. Okay, and yes, $900 favorable is the right answer. Okay, and we'll be doing that again multiple times today. So if you didn't quite get it, hopefully you get it by the end of our session. C, what is the total direct material cost variance? Okay, to get the total variance, you take the price variance and the quantity variance, and you add them together. So we just figured out quantity variance, right? What is the price variance? You remember? $250, exactly. That was given to us. We didn't even have to figure it out. And that was unfavorable. And remember, unfavorable is a positive number, favorable is a negative number. So we have to add these two together. We can take $250, our unfavorable price variance, plus negative $900. And we get negative $650. Again, it can be a little tricky adding a positive and a negative number. If you understand how they work, you could just take the positive number, like you could just take 250 and say minus 900. In case that doesn't make sense to you, you could just think of it as $250 plus negative 900, and you get the same answer. So whatever works for you. Or you can find the difference between the two, right? The difference between 250 and 900 is 650. And because the negative number was bigger, we know the answer is negative. Okay, so multiple ways to look at it. All right, so we got C down. Any questions on that one? So D says, what if 9,500 pounds were used to make these ladders? So this is a hypothetical. What would be the direct materials quantity variance? So this was our direct materials quantity variance that was based on 8,800 pounds. But now they're asking us to do this again based on 9,500 pounds. So we'll put 9,500 pounds times the standard rate. And the right side is going to stay the same. The only thing that they changed was the actual quantity. They didn't change any standards. And this was standard quantity and standard price. So those stay the same, which means that this total is the same. And so now we have to recalculate the total on this side. 9,500 pounds times the standard price would give us 42,750. What's our next step?
subtract the 42,750 or
Okay.
subtract 40,000 from.
Exactly. I'm gonna take the left side, subtract the right side. And we get 2,250. Is that a positive number?
Positive, but it's unfavorable.
So it's unfavorable. That's exactly right. Because it's positive, that means that in that case, if we used 9,500 units or pounds of material, that's going to cost more than the standard because we were really only supposed to use 9,000 pounds, right? So that's why we got a positive number, and it's an unfavorable cost variance. If you feel lost, hang in there, okay? It is confusing. Any questions on D? Let's go to E. Now they're asking if there were a $340 favorable direct materials price variance, then how much did they pay for the material? Okay, remember how we solved this at first? The very first question was how much did they pay based on 8,800 pounds? And what, I think it was Zay, right? You said you take the 8,800 pounds times 450, and then we added the unfavorable price variance. So this time we're going to do the same thing. We're going to take the 8,800 actual pounds times the standard price, and then to figure out what the variance is, because it's a favorable variance, we're going to subtract it. So I'll check and make sure that's right. 39,260 is right. Okay. We could have used one of those tables on that one as well, but we spent enough time on this exercise. So just to review what we just did, again, to figure out what would be the amount that they paid if there had been this variance, we have to figure out, well, what would be the standard cost? We took 8,800 actual pounds that were used times the standard price. Now we know what was the standard cost for that level of production. But then to see what a $340 favorable variance would be, we just subtracted that amount to show what would it look like if they saved $340 compared to the standard. And that's how we got our 39,260. Okay. All right. Shall we move on? I think we shall. Number 6. All right. First thing we need to figure out, what is the standard price paid for materials? Okay, this is one of those cases where they only give us partial information. So it's kind of hard to answer that question. If you're really good at these sorts of problems, you might find an easier way to solve it. But like I said, I find the easiest way is just using these long form formulas. So if what we're trying to figure out is the standard price paid for materials, what we could do is look at our formulas. These are our materials formulas. And let's find one that has standard price, but only one time. So for example, this first formula will work because here's standard price, but it's only there one time. So that means if we have all the rest of this information, we can figure out standard price, basically solve for X. If we wanted to use the second formula, you see how standard price is in there twice. So that's not really going to work. Maybe we could use this formula. But let's just go ahead and use this first one. So again, actual quantity times actual price minus actual quantity times standard price. Okay. Again, what we're trying to figure out for A is the standard price. So let's see if we have all the other information. Pounds of material used. Does that sound like the actual quantity? It does, because standard pounds is the standard quantity, right? So the pounds that were used is the actual quantity. So let's go ahead and put that in. Okay. Actual price, we have that as well, $14.50 per pound. And now we will be able to figure out the missing information. But how, you're wondering, right? How do we do that? Okay, well, we're going to start over here since we've got all that information. We're going to take the actual quantity times the actual price. We get 192,125. And then the other thing that we need, since we're using the direct material price variance formula, we need to know the direct materials price variance. And they gave it to us right here. Favorable would be negative 4,637.50. Right? Favorable is negative when it comes to cost. So what that tells us is that this amount is less than this amount by 4,637.50. And so now we can figure out what this amount is. What are we going to have to do here? Add it, exactly. So 196,762.50. And now our last step, how can we figure out our standard price here? Exactly. We divide it by the 13,250 and we get $14.85. Okay, so that is our answer, $14.85 per pound. Okay. Any questions on what we just did right there? No? Okay. So let's go on to B. What is the direct materials quantity variance? All right, so if we look back at our formulas, direct materials quantity variance is the second formula here. And remember, I mentioned this on Tuesday, this part of the price variance is this part of the quantity variance, right? You have actual quantity times standard price on the right, in the price variance, and you have the same actual quantity times standard price on the left for the quantity variance. So we can save ourselves a little time by just doing a copy paste from that formula down to this formula. And then we have to fill in the rest of the formula, which is standard quantity times standard price. Okay. We know what our standard price is because we just calculated it. Standard quantity is up here. It's the 12,500 standard pounds. So then we can just continue with our calculations. Then again, take the left side, subtract the right side. That's a positive number, so that means it's what? Unfavorable. All right, very good. And that is correct. Eliana, make sure you put your name on the list. Any questions? All right, so let's go to C. What is the total direct materials cost variance? How do we get the total again? We've got the price variance, we've got the quantity variance, we add them together. Exactly. So you can take the positive number plus the negative number. Or find the difference between the two, whatever works for you. So it comes out to $6,500 positive, which of course would be unfavorable. Okay. Part D, if the direct materials price variance were unfavorable, then what would be the standard price? Okay. So in other words, they want us to redo this one, but with a positive number here to figure out a new standard price. So this part's going to be the same. The actual quantity and actual price are going to be the same. This, they're telling us, is going to be a positive number because it's unfavorable. So now we just have to complete the rest. Okay, and that will tell us the new sales price. So remember what we had to do up here is we had to add that amount. So this time, since it's a positive number, we'll have to subtract it. And if that doesn't make sense to you, I'll explain in just a moment. Okay, so why are we subtracting here? Well, remember what this says is that this is an unfavorable amount. In other words, the number on the left is higher than the number on the right, which is the standard. So if the number on the right is higher, we have to subtract this. No, if the number on the, I said that wrong. The number on the right is lower, we have to subtract it from the number on the left. Okay. And then our final step to figure out our new standard price.
Divided by the 13.
Divided by the 13,250. And in this case, our standard price would have been $14.15 per unit. Per unit of materials. Ooh. We're only on exercise 6. All right, any questions on this one? Okay. All right, let's move on to number 7 then. Got Dog Bone Bakery. They make biscuits for dogs. Each biscuit uses 0.75 cups of flour. Okay. They buy 4,000 cups at a price of 55 cents per cup. They use 3,550 cups to make 4,750 biscuits. And the standard cost for a cup is 53 cents. Okay. Here they're asking, what are the direct materials price variance and the direct materials quantity variance and the total? So this is not too bad. We're just going to go ahead and plug in our formulas. Actual quantity times actual price minus actual quantity times standard price. That'll be our price variance. And down here, we have actual quantity times standard price minus standard quantity times standard price. That will be our quantity variance. And then we'll add the two together to get our total variance. Okay, what is our actual quantity of flour that we used? 3,550 cups, right? So we can put that everywhere where we have actual quantity, 3 different places. What is our standard quantity? For this level of production, what would be the standard quantity of flour we would use? The 4,750 is how many units we made, right? How much flour would we need to make that many units?
0.75 per unit.
Okay, right. So 4,750 units times 0.75 cups per unit. So the standard would be 3,562.50 or 0.5. That's kind of a weird number, so let me make sure that that's right. Yeah, okay. They actually put 0.51. Guess that's a rounding difference. Okay. So we'll go ahead and go with the official number there. All right, what is the actual price per cup of flour? 55 cents. Exactly. That's what it says. So we'll put that in, whoops, under actual price. And what is the standard price? 53. Exactly. Okay. And again, that goes in 3 different places. 2, 3. Okay. So if you get the right numbers in the right places, then it's just a matter of doing the calculations. So let's go ahead and start. 3,550 times 55 cents gives us 1,952.50. And on the right side, 3,550 times 53 cents, 1,881.50. And again, that's going to be the same number down here. And then the last one, 3,562.51 times 53 cents. Okay, we're going to round that off to 1,888.13. Yep, that's what they did. Okay. Then we're going to take the left side, subtract the right side for each of these 2 formulas. Here we get a positive $71. That's $71 unfavorable price variance. On the bottom, we get negative 663. So that is a $6.63 favorable quantity variance. And then if we add the 2 together, we end up with a positive number, 64.37 unfavorable. I hope. Let's see. Oh, good, that's right. Okay. Get a little worried on these things sometimes. Any questions? Right, let's see. So the last part of this one is, what is the standard cost per biscuit for the semolina flour? They gave us the standard cost per cup. And now they're asking for the standard cost per biscuit. So how do we figure that out? Okay, so yeah, 53 cents is the standard cost for a cup of flour, and multiply by the 0.75 cups per biscuit. Okay, so we take the standard cost per unit of materials times the 0.75 units that we need per unit of production. That's confusing. And we get 39.75 cents. So that is, believe it or not, something you sometimes do see in the business world. Prices that are in fractions, you know, not in whole pennies, but in actually fractions in between. So this is 39.75 cents, which if you're buying thousands of units, then obviously that fraction of a penny makes a difference. Okay, so 0.3975 is the answer there. We ready for the next one, number 8? Right. So let's see here. 2 hours of labor are required for 1 unit of product. They produce 12,000 units of product. Standard cost was $90,000. There was an unfavorable direct labor time variance of 5,520. Okay, first question, what was the standard cost per hour? Now this is one where, again, you might be able to figure out some easier ways to solve it. I think we should go ahead and use those tables. I'm just going to copy this table here. We'll use that once or twice here for this particular exercise. Yeah. So if we need to figure out the standard cost per hour for labor, but here are our labor formulas. Standard rate per hour. Again, if we look at this first formula, we have standard rate per hour only one time. So if we have all of this other information, we'll be able to figure this out. Oops, too many clicks. So it's going to be actual hours, because that's what we call quantity when we're talking about labor, times actual rate minus actual hours times the standard rate. And the standard rate is what we're trying to figure out. So let's see if we have all the other information. What are the actual hours of labor? Do we know that?
Well, it would be 2 hours per unit and 12,000 units. So the
Well, that's the standard, right? It says it requires 2 hours of labor. If it said it required 2 hours of labor, then we would know that was something that actually happened. But this is.
Wouldn't it be easier to just multiply the 2 hours? Divide that.
Maybe, maybe. So let's try that. We take 90,000 divided by the standard 24,000 hours. I think that's right, Drew?
It is.
Make sure. 375. Okay, so that worked out right. Since we actually didn't have enough information to do it the way I was planning to do it, if you didn't quite follow Drew's method, because it takes being able to think about these abstract numbers and see how they work together. And sometimes my brain can't handle that. We could have looked for another formula. Sometimes you have to go to the more simplified formulas. Like here's one that has standard rate only one time. Did we have all of this information? Let's see. We had the time variance, but not the quantity variance. Oh yeah, we did have the time variance. Did we have actual hours worked? Again, we didn't actually have that, did we? We had the standard hours. Yeah, I actually can't even tell you, other than using the Drew's approach, I can't tell you an easier way. Actually, let's see how the official answer did it. They did it exactly the same way Drew did. All right. Okay, so there might be an easier way that I just can't think of at the moment. So the standard cost per hour was $3.75 of labor. Okay, so now how many actual hours were worked? So how can we figure that out? If we take the standard labor cost of $90,000, okay, that's what it should have cost for that amount of production. And we know that there was a time variance, meaning we worked more than we were supposed to because it was unfavorable. So we'll add that unfavorable time variance. That gives us 95,250, right? 90,000 plus, oh, I'm sorry, 90, let's clear that. 95,520. And if we divide that by the 375, standard cost per hour, we get 25,472. Why people are working for $3.75 an hour, I don't understand. I think that's illegal in most cases. Let's see, if that didn't make sense to you, I think there's probably another way we could solve that one. So if we did, we were trying to figure out the actual hours. Okay, we could have used this. Oh, we didn't, yeah, I think we could use that. And variance, yeah, we could use that one. So we could use this formula here, actual hours, which we don't know, times standard rate, minus standard hours times standard rate. Let's just go ahead and do that real quick. Okay. So again, if we didn't know this answer, if we weren't sure how to find that number, we could, or we didn't know actual hours here, we could put the standard rate. That's what Drew figured out there for us. Sorry, come on. Okay. And then the standard hours would be the 24,000 hours, right? 2 hours times 12,000 units. 2 hours is the standard. So for 12,000 units, that would be 24,000 hours. And the standard cost, 90,000. And the unfavorable direct labor time variance is this 5,520. Okay, since it's unfavorable, it's a positive number. That means this number is more, right? So this is 95,520 over here. Then we divide by the 375. And that's how we got 25,472. Okay, I don't know if that helps at all. To me, it makes more sense if I go through it that way. And so that is our actual hours. Any questions? All right, well, let's look at part C. If the workers were paid $3.90 per hour, so if that were the actual rate, then what would be the direct labor rate variance? Okay. Well, direct labor rate variance is not this formula that we were looking at. That was the time variance. So the rate variance would be actual hours times actual rate times, minus actual hours times standard rate. Okay, here we already have actual hours times standard rate. So I'm just going to copy that over. And actual hours, we know, are 25,472. The actual rates, it says if they were paid $3.90. So that is the actual rate in this scenario. And so now we can do the rest of the calculations and we'll figure out the answer. Oops. Okay. We subtract the right side from the left. I get 3,820 and 80 cents. That's positive, so it's unfavorable. That should be our answer. And it is. Okay, so the answer for C, $3,820.80, unfavorable. Okay, how are you liking this chapter so far? Brutal, right? Okay, well, let's keep going here. We're making progress. How many exercises did I say? 14. The last 3 are very similar, so that'll be helpful once we get there. Okay, so moving on to number 9. All right, they give us some information there. Oh, this one's really different. Yeah, okay. So they give us the information in the gray box. They tell us the company used 12.5% more hours than the standard. Okay. What were the total standard hours allowed for the units manufactured during the month? I think this is one of the hardest ones to figure out. So I'm going to keep it pretty simple. But does anybody think they have an answer? What were the standard hours allowed given the information that we have? Okay, I'll just tell you, right? Okay, what we can do is take this time variance, because that tells us it cost us an extra $25,000 because of how much time we used. And we know that we used 12.5% more hours than was allowed. So if we can convert this $25,000 cost into a number of hours, we can then figure out what that is 12.5% of, and we'll have the answer, right? I know that's what you were thinking all along, right? So in other words, in this one, if we take the time variance of $25,000, divide that by the standard rate of $25 per hour, that means we used 1,000 hours more than the standard. And if we want to know what that is 12.5% of, how can we figure that out? I think if we divide by 12.5%, we'll have the answer. We do. So that means the actual standard hours allowed were 8,000. Okay. Again, we took the labor time variance, divided it by the standard rate. We got 1,000 hours, divided that by 12.5%, and we got our standard hours. Then it asks, what were the actual hours worked? Well, actually, that one's not too hard. Because if the standard hours were 8,000, and we know that we worked 1,000 hours more than that, that means we actually worked 9,000. And the last one says, how many actual units were produced during May? So anyone want to take a guess on how we solved that one?
So 8,000.
That is it, Drew. Man, did you take this class already? You're just good with this stuff. All right, so if we take the 8,000 standard hours, divide it by the 2.5 units per hour standard, we get 3,200 units produced. That is correct. You want to tutor next semester?
Here, yeah.
All right, let's talk. Actually, that goes for anybody. I mean, Drew would do a great job. If anybody is interested in tutoring next semester, let me know. The Panther Learning Lab does pay if you tutor. You can do it part-time. All right. Any questions on exercise 9? All right, so let's go on to number 10. All right, now we're into variable overhead. So variable overhead has a rate variance and it has an efficiency variance. So again, the formulas are the same, the words are just different. So what we called a quantity variance for materials and we called a time variance for labor, we call an efficiency variance for overhead. Okay, but the formula is the same. So what we need to plug in here would be the actual, in this case, it's hours because they're basing their overhead on machine hours. So actual hours times the standard rate minus standard hours times the standard rate. Okay, and I'm just getting that here from right here, from this formula. So actual hours, they tell us are 10,000. standard rate is $4.50. So that goes in 2 spots. And standard hours are 9,500 units. Okay, so let's see if this comes out right. We subtract the right side from the left. We get 2,250 positive number, which is unfavorable. So that one didn't have any tricky parts to it. It was just a matter of putting in the numbers. And yes, we got the right answer. All right. Anybody need time on that one still? No? Okay. So number 11. A manufacturer planned to use $78 of variable overhead per unit. So that was their standard. But they actually used 76. So that is their actual rate for overhead. They plan to produce 500 units. So that is their standard quantity. They actually produced 540. So that's their actual quantity. And here it's asking for the variable overhead spending variance. So what they mean is the variable overhead rate variance. For some reason, they changed the terminology on us. But this is the formula we need for this one. So we take actual hours times actual rate. Actually, in this case, I'm sorry, it's not hours because the only thing that they gave us to go by is units. So we're going to do actual units times actual rate minus actual units times standard rate. So how many units did we actually produce? 540. Okay, so that goes on both sides. What is our actual rate of overhead? 76. What is our standard rate? 78. So this one wasn't tricky either. Just the terminology was tricky because they changed it on us. Okay, and then if we subtract negative 1,080. Yeah, good, that came out. So that would be favorable, right? Because it's a negative number. So our variable overhead spending variance or rate variance was $1,080 favorable. Right, and the last 3 that we're going to do on the exercise set are a little time consuming, but they're not tricky. So we'll just go through those kind of quickly. In fact, I'm going to cheat a little bit to save us some time. And yeah, it looks like we're doing okay on time. So I think we'll probably take a break after the exercise set, even if it's a little ahead of our break time, because we got some difficult problems coming up and we could all use a little break, I'm sure. All right, so here they give us all the information we need. Yay. we don't have to hunt for the information. And we have to do price variance for materials and quantity variance, and then we have to do both a rate and a time variance for labor. Again, little time consuming, but I'm just going to go through it quickly. Tell me if I'm going too fast. All right, so we're going to take actual quantity times actual price minus actual quantity times standard price. Quantity variance, actual quantity times standard price minus standard quantity times standard price. And for labor, it's going to be actual hours times actual rate minus actual hours times standard rate. For efficiency, the right side, it's going to be standard hours times standard rate. Okay. In fact, because the next two are similar, I'm just going to go ahead and put those in for reference. You don't have to do this, but it'll just save us a little time when we get to it. Last one. Okay. Okay, so back to number 12. Now we're going to fill in the numbers. Actual price paid for material is $1. And so again, that goes in 3 places here. I'm sorry, I put that in the wrong place. It's supposed to be quantity. Actual price is only one time, and it goes right there. My bad. Quantity is actually 100. That's what we're going to put where it says actual quantity. I think I need a break just as much as you do. All right. Then standard price, it says is $1.20. That's going to go in 3 different places here. And standard quantity is 110. Okay. Everybody with me so far? Okay, so now we can start doing our calculations. Actually, some of these we don't even need to calculate with the calculator. So this would be 100, this would be 120. Subtract, we get negative $20. And that would be $20 favorable. Down here, we got 120 on the left, 132 on the right. Subtract, you get negative $12, and so that again is favorable. Okay, I'm going to go ahead and start working. Oh, I see. I have to put in the numbers. Okay, actual hours of labor is 200. Actual rate of labor is 15. Standard rate 16. And standard hours is 220. Okay, I'll start doing the labor calculations. Were there any questions on the materials? All right, so this would be $3,000, 3,200. And this is 3,520. Okay. So we end up with the labor rate variance of $200 favorable and an efficiency variance of $320 favorable. Okay. So that's part A for this exercise. Any questions? Part B asks us to describe the causes for these variances. So to review, we're paying less than the standard for the price of our materials. We're also using less than the standard for our materials. We're using a lower rate of labor, and we're using less labor. So it's favorable all the way around. So what might explain this combination of all four areas here being favorable? Any guesses?
We're making less units.
Well, that wouldn't change the
This is
cost
on
per
units,
unit.
isn't it?
Yeah, yeah. Yeah, so that wouldn't be it. But imagine we're buying better quality materials than we bought in the past. And because they're better quality, we don't need to use as much of them. Our workers don't have to work as many hours. And we can use workers who are less skilled. And you'd have to assume that our supplier is also charging us less than we used to pay, which is kind of not that common, that you get a better quality product for cheaper, but that could be one explanation.
But what about?
What about what? Yeah, well, if the standards were off, okay, that could be it too. That's a more likely answer. So let's go ahead and put both. The standards were too high, or the material we are using is cheaper, better quality, and less time consuming to use, allowing for a lower skilled worker. So without more information, we don't know exactly what the reason is, but those would be some possibilities. Okay. Are we ready for the next exercise? Anybody need more time on this one? Okay. So as I said, 13 and 14 are similar. So we're going to cheat a little bit. In 13, the only thing that's different is the standard price for material. So the labor part is exactly the same. I'm going to see if it's going to just let me copy and paste here for the labor part. Okay, that worked. And for the material part, and the only thing that changed was the standard price. It changed from $1.20 down to 90 cents. So that means this part is exactly the same. I'm going to go ahead and copy this down. Okay. And then let's go ahead and get this on a new page. All right, so for number What's this, 13? The difference is standard price is 90 cents. Oops, what did I do? Oh, I put it in the wrong place. That's what I did. Goes here. There we go. Okay, so for number 13, actual quantity times 90 cents is $90, which gives us a $10 unfavorable variance. And again, you can copy the right side of the first formula down to the left side of the second formula. Standard quantity was 110 units, right? Sure, that's right. Which would be $99. Subtract, and we get negative $9. And so we're $9 favorable. Okay, so in this case, again, the labor is all the same. Because of the different standard price, I had to change some of the numbers here. And we ended up with a $10 unfavorable price variance for materials. We're still favorable for materials quantity variance, but this time it's $9. And we're still favorable on our labor. So in this scenario, we're favorable all the way around except for the price variance. So the reason might be the same as the first one, except that we're paying a higher price for these better quality materials. I'm just going to copy down the same thing, and I'm going to take out the word cheaper. I'll just replace it with more expensive. Okay. We're almost at break time anyways. All right, how many people need more time on this one? Anybody? No? Okay, so let's go ahead and move on to the number 14, the last one. Again, this one's similar. The thing that's changing here is the standard labor rate per hour. So the materials part is exactly the same as what we just did. If you want to do a copy paste, you're able to. Let's see if it works here. Can be a little tricky sometimes in a Word document. But it looks like that worked. Okay, so that part's exactly the same. The labor is going to start out the same because the actual rate is the same, but then we're going to have to do a modification here because the standard labor rate is $14. And so that's a difference of $200 unfavorable on the rate variance. And again, you can take the right side of the first formula, make that the left side of your second formula. And standard hours, I believe, is 220. Yep. And standard rate. Okay. giving us negative $280. So our efficiency variance for labor is 280 favorable. All right. Make sure. Yeah, that's what it says. Let me get this situated better on the screen so you can see the whole thing. Okay, so again, the materials was exactly the same as the last exercise, number 13. With labor, we ended up with unfavorable rate variance and a favorable efficiency variance. So how can we explain these variances? Kind of similar to the last one, right? The one difference is our labor rate variance is higher. So that suggests we need a higher skilled worker. Otherwise, it's pretty much the same. So again, I'm going to do a copy paste and a slight change. I'm just going to say requiring a higher skilled worker. I guess the standards, I'll say instead of too high, were inaccurate. Because some were high, some were low. Right, any questions on our exercise sets? All right, well, we are a little ahead of schedule. Let's go ahead and take our break for 10 minutes. And when you come back, we'll knock out the problem set. So see you in 10. Okay, this first one is really just a simple question here. The comptroller, which is somebody that's basically typically in charge of the accounting function, wants to set the standards according to a study done by a consulting firm. These were the assumptions that were used in coming up with these standards. First assumption, the machines will never break down. And the workers will never take a break. Actually, that sounds illegal, right? By law, you have to give your workers a break if they're hourly. The material that is used is perfect. The material arrives on time. No one takes a day off. And workers are well trained. And workers do not make defective units. And the question is, first question, what kinds of standards are these?
Amazon warehouse standards.
I love it. Amazon warehouse standards. Okay, exactly. The way the textbook describes it, they would be called ideal standards. So that is the first part of the answer, ideal standards. And the second part, will the workers be motivated to achieve these standards? And if you ask an Amazon warehouse worker, probably not very motivated. Workers will not be very motivated. Okay? Because it's unrealistic, right? Things go wrong. Things are not always perfect. And so you need to account for that in setting standards. So that wasn't really hard. It was just kind of an unusual problem. And let's go ahead and go on to numbers 4 and 5. I don't know why that keeps popping up. Okay, this one's not too bad. So this company, let's see, they purchased 60,000 feet of material for $300,000. It takes 5 feet of raw materials to make 1 unit, which is a park bench. They produced 10,000 benches. Standard cost was $10,000. I mean, $100,000, sorry. And they had an unfavorable direct materials quantity variance of $6,000. Okay. First question, what is their standard material price for 1 unit? So this one's not that complicated. Can anybody tell me how would we figure out their standard material price for 1 unit of product? $100,000 is the standard cost. They produced 10,000 park benches. So that gives us $10. That would be the standard cost per unit of product. But it's asking the standard material price. Well, standard material price for 1. It's not clear. Actually, the question is not clear because what they actually mean is 1 unit of materials.
So it would be a foot of raw material rather than a whole bench.
Yeah, yeah.
So then you would take 300,000 divided by 60,000. That'd be the price.
Well, that's actuals, right? Those are actuals. So Drew was on the right track and he actually answered the question because the question is really not worded very well. So to figure out the standard material price, again, it should say the standard price per unit of materials is what they should say. Right. Because the standard cost is $100,000. They made 10,000 units, so that's $10 per unit. But it takes 5 feet of raw materials, so that means it's $2 per foot of materials. Right? Because 10 divided by the 5 feet equals 2. So that is the right answer. And actually, I think I will change the wording on that question because I see why that would confuse people. You're probably thinking the whole chapter is confusing, right? But this is deceptively confusing. Okay, so that is our answer, and I think it goes right there, yeah. Okay, so let's go on to the second part, B. What was the total number of units of material used to produce the August output? So in other words, what was our actual quantity of material? And if we look at our formulas, again, if we use this formula, we see actual quantities there only 1 time. So if we have direct materials quantity variance and all this other information, we can solve it. We do have the direct materials quantity variance. It's unfavorable, so it's a positive number. And that formula, actual quantity times standard price minus standard quantity times standard price. We just established the standard price for materials is $2, right? So we can put that in. What's the actual quantity? Oh, no, that's what we're trying to figure out. What is the standard quantity of materials to make 10,000 benches? Yep, 50,000 feet, right? Because it's 5 feet per bench times 10,000 benches. So the standard is 50,000 feet. Okay, so now we have enough information, we can solve the missing piece. We take the 50,000 standard feet of materials times the $2 standard price. You get $100,000. Now, if the actual cost is $6,000 unfavorable, what would that actual cost be? $106,000, right? Because that means the left number minus the right number gives us 6,000. Now we can take that $106,000, divide it by the $2 standard price, and we get 53,000 as our actual quantity of square feet or feet of wood, whatever it is, materials. So that is our answer. The total number of units of material is 53,000. Okay. Then what was the direct materials price variance? So that is the other formula, right? We just used this one. The price variance is this one, which means that the right side is going to be the same as the left side that we just filled in. So I'm just going to do a copy paste here. Over here, we're going to have to put actual quantity times actual price. Well, we know the actual quantity is 53,000. What is the actual price we paid for the materials we purchased? Okay, how'd you get that, Zay?
300,000 divided by 60.
Okay, so the actual cost of $300,000 divided by the 60,000 feet we purchased, whether we used it or not, gives us a $5 per foot rate. So that is our actual price. And the rest is just a matter of calculations. So we end up with 159,000 unfavorable variance. Why, if our standard price is $2 per foot, we're paying $5 per foot? I don't know. Inflation, I guess. But that added up to $159,000. Any questions on number 4? No? All right. Well, next we'll do number 5. Are we ready? Got to keep an eye on the time here. I think we will finish on time. All right, so this one we've got 2 products and 2 materials. The products are O-rings. Those are those, I don't know if you've ever seen them, the little black rubber rings. They're circular and they're used in like pipe fittings and things like that. And we've got 2 different sizes. So we have a large O-ring, we have a small one. All right. And then we also, each one is comprised of rubber, but it also has a connector. So those are the 2 different materials. Okay, at the beginning of the month, we bought 25,000 feet of rubber. Okay, that's the amount we purchased. And this was how much we paid. We made 3,000 large O-rings, 4,000 small O-rings. Used 14,500 feet of rubber. Up here, we see the standard quantity and price for each material. Note though that the small O-ring uses less material. Okay, so it has a different quantity. Okay, and we have to figure out direct materials price variance and quantity variance, and then a total. Oh, just for the rubber materials. Okay. So we'll use our first formula first. Actual quantity times actual price minus actual quantity times standard price. And second formula, actual quantity times standard price minus standard quantity times standard price. Okay. Then we fill it in. So what is the actual quantity of rubber material that we used?
14,000.
How'd you get that?
It says the company used 14,500 feet.
Okay, yes, there it is. Thank you. 14,500 feet is the actual quantity we used. Good job. I misheard the number you said and I was confused. Okay, so that's our actual quantity. And what would be our standard quantity? Gonna have to do some calculations to figure that out. What would be the standard quantity for the 3,000 large O-rings?
Sorry, 9,000.
9,000, yeah. It takes 3 feet of rubber. These must be really big O-rings. 3 feet times 3,000, right? So that's 9,000 feet of material for the large. And we got 4,000 small O-rings times 1.25 feet. 4,000 times 1. Oops, sorry, try that again. 4,000 times 1.25 feet per unit. That's 5,000 feet for the small O-rings, plus the 9,000 feet they calculated for the large O-rings. Together, that's 14,000, right? That would have been our standard quantity. Does that make sense to everybody? Okay, what was our actual price for the rubber material? Here, we're going to have to take the actual amount that we spent, 6,875, divide it by the 25,000 feet that we purchased, even though we didn't use all of that. And we see we paid 27.5 cents per foot. That was the actual price. What was the standard price per foot for rubber? 25 cents, right? Tells us here and here. Okay, so we'll put that in as the standard price. Now we can solve the problem. Looks like 362.50 unfavorable is our price variance. And $125 unfavorable, oops, is our quantity variance. And the total variance, again, we can combine the two. Did it ask for total? Yeah. So the total would be $487.50. Didn't really give us a place to put that. Unfavorable. Yeah, well, what number are we on? Anybody know? 5? Okay. That sounds right. $487.50. Good. Okay. I hope it's starting to make some sense to you. I know it's a tough chapter. Any questions on this part A? All right, let's go to part B. If they bought 10,000 connectors, that's the other material here, and they cost $310, what would be the direct materials price variance? So again, that's the first formula. So they're saying the actual price was $310. And we're trying to figure out what's the variance. So first thing we need here is the actual quantity of connectors. If it takes one connector per O-ring, regardless of the size, they made 7,000 O-rings, that means they need 7,000 connectors, right? So the actual quantity here is 7,000. The standard price for the O-rings is 3 cents. They gave that number to us here, 3 cents. And let's see, the actual price we can get. Anybody want to tell me how we get that actual price?
310 divided by 7,000.
Yep, 310 divided by 7,000. All right, wait a minute. Wait. All right.
That's right. Yeah.
Oh, I'm sorry. No, actually, we used 7,000, but we bought 10,000. So it's 310 divided by 10,000. So it's 3.1 cents per connector. Slightly more than the standard. Oh, you know what though? I take it back. This number does not go here. Okay. So let me clarify here. We are using 7,000 connectors, right? And we know the standard price is 3 cents each. So that comes out to $210. Over here, again, 7,000 actual quantity. And then to get the price, we took the $310 we spent divided by the 10,000 we purchased, and we got the 3.1 cents. Now we need to do this calculation over here. $217 minus 210 gives us a $7 unfavorable variance. Okay, any questions? And then part C says, if there were, I wish they would correct the grammar here. If there were an unfavorable direct materials price variance of $125, then how much did they pay per foot of rubber? So since it's talking about direct materials price variance, that's our first formula. That's this one, direct materials price variance. And they're saying it's $125 unfavorable. We know that's a positive number if it's unfavorable. So what we're going to have to do here is redo this one with $125 here. So we're going to keep actual quantity and actual price, I believe. Let's see. No, we have to figure out the actual price. We're going to keep the actual quantity and the standard price. Yeah. And then we'll have to figure out the rest. So if the actual price was $125 unfavorable, is it going to be more than the standard or less? Be more, right? So we're going to add that over here, 3,750. Now, if we divide that by the actual quantity, we'll get the actual price. And we'll just round that to 26 cents. Yeah. Any questions? Okay, then. So we've done 1, 4, and 5. We have 7, 8, and 11. Okay. Seven. All right, Drew, we might need your help on this one. All right, they give us some information here. First thing we need to compute is the standard direct labor rate per hour. This is one where I think if we use, one of the formulas, we could do this. They give us direct labor rate variance. And we have to figure out the standard direct labor rate. I think this formula might work here. And they give us direct labor rate variance. We're trying to figure out standard rate. If they give us the actual rate and the actual hours, it should be okay. The actual hours are here. The actual rate is here. I think this is going to work. So let's look at this formula. This is a simplified formula. Direct labor rate variance which is 8,137.50, right? That's the direct labor rate variance, equals actual rate per hour minus standard rate per hour times actual hours. Okay, I think this is going to work here. Actual hours again was 10,850. Actual rate is $32. We're trying to figure out the standard rate. So if we take direct labor rate variance, divide it by the actual hours worked, we get 75 cents. So we see $32 minus this should be 75 cents. Right? That would be 31.25. See if that's right. Mm, 32.75. So I got it backwards. I had to add 75 cents. Okay. We were close. Does anybody have an alternate way to figure it out? We're kind of running low on time. We could try it with one of the other formulas, but since we don't have time, we know the answer. We'll just keep going. Okay, now compute the direct labor time variance. Okay, well, with that one, we can use, well, maybe let's see if we can use this shorter formula. We take actual hours minus standard hours times the standard rate. So actual hours minus the standard hours, so that's negative 150 times the standard rate we just calculated. Let's see if that's right. Doesn't look right. No, it's not right. What did I do wrong? Let's see. Actual hours minus standard hours times the standard rate. Actual hours minus the standard hours. Yeah, that didn't work. Okay. Well, the other way we could do it, we are trying to figure out the time variance, right? That's going to be the actual hours times the standard rate minus standard hours times standard rate. So actual hours is 10,850. Standard rate is the 32.75. Standard hours is 11,000. Should come out the same. Okay, let's cheat. Where did that come from? So they're saying, okay. They're saying this is the answer. 2009, 12, 50. Let's go with that. Okay. I'll take a closer look at this later, and when I have more time. Then let's see, our last question, compute the standard direct labor rate if the direct labor rate variance was this. Okay.
If the direct labor rate variance standard, okay, so you know what, I think we're gonna have to go with one of our tables. For me, that's just the only way it makes sense. Okay, let's see if we can at least get this last part right. We need standard direct labor rate, the standard rate. And we have the labor rate variance. Okay, so we're going to need the first formula here, actual hours times actual rate minus actual hours times standard rate. We know the standard rate is $32.75. We know the actual rate is 32. Actual hours is 10,850. Oh, actually, in this case, the standard rate is going to be different. That's what they want us to calculate, right? Okay. All right, so let's solve this one here. Since this is unfavorable, right? Unfavorable. That means we have to subtract it. Divide that by the actual hours, and we get a rate of 31.75. Okay, and that is correct. That is our standard direct labor rate for part C. That one came out. See how much easier it is if we use the table? Okay. So I'll tell you what, we have about 10 minutes left. We need to do problems 8 and 11. All right, 8 and 11. And let's go ahead and get through those. And then if you want to stick around, great. If not, that's fine. But I'm going to go back through number 7 and get it right. So if you want to see the right way to solve it, I will cover that. But I just don't want to keep anybody late. Okay, so problem number 8. What is the actual direct labor rate per hour? Okay, we have actual labor cost. We could divide that by the actual hours worked, and we'll get our actual rate. Sounds too easy to be true, but I think that is correct. 23.50. What is the standard rate? Okay. Well, we have to first figure out what the standard cost would be. So if the actual cost was unfavorable, that means the standard would have been lower. So we have to take this 1,128,000, subtract variance to get the standard cost, and divide that by I think it's the actual hours. Make sure though. Well, they do it a different way. Okay, let's see if my way works. Close, not quite. So let's see what they did. They took the variance and divided it by the difference between actual hours and standard hours. Okay. So 13,800 divided by 600 gets us $23. All right, so that's the easier way to do it and the right way. Then we get standard direct labor cost for May, okay? Well, standard direct labor hours allowed times the standard cost should give us the right answer, 1,090,200. And what was the direct labor rate variance for May? Okay, I'm just gonna do that one. Just gonna do the table method here. Okay, rate variance, the rate variance. So that's actual hours times actual rate minus actual hours times standard rate. Actual hours is 48,000. Actual rate is 2350. Standard rate is 23. Okay. And then that should get us the right answer. Okay, and that's a difference of 24,000, which is the right answer. So it is 24,000 unfavorable. Okay. So yes, 1,090,200 for C, 24,000 unfavorable for D. Okay, any questions on number 8? All right, well, our last problem, and then like I said, I'll go back to number 7. This one is very, very confusing, but I do know how to do this one. And it won't take us very long. So we're trying to figure out variable overhead efficiency variance. That's basically the quantity variance. And it's based on direct labor hours. That's how they're applying their overhead. So it's going to be actual hours times the standard rate minus the standard hours times the standard rate. Actual hours is 18,000. Standard hours is 17,000. The hard part on this one is figuring out the standard rate. And the reason they gave us a total factory overhead rate, but that includes both fixed and variable overhead costs. So what we have to do on this one is figure out how much of that is fixed, subtract it, and then we'll know our variable overhead rate. How do we figure out how much is fixed? Well, we have to take the budgeted fixed overhead costs of 42,000, divide it by the activity level they based that on, which was 15,000. We get $2.80 per hour. Subtract it from this $4.35 rate, which is the total. And that is our variable overhead rate, $1.55 per hour. I never would have expected anybody to figure that one out. I didn't figure it out. Even looking at the answer, I couldn't figure out how they came up with it for the longest time. But maybe that's just me. So when we then plug those numbers in, we get 27,900 over here. We get 26,350 over here. Subtract 1,550, it's a positive number. So that is our answer, 1,550 unfavorable. Number 11. Okay, and that is the right answer. So we are officially done, but I am going to go back over problem 7. So if anybody wants to stick around for a few minutes, feel free, but I'm going to go ahead and pause the recording for a moment. Okay, so back to problem 7. I'm going to try to solve A and B without cheating this time. So for A, I'm going to try using direct labor rate variance. So we know that that is 8,137.50 favorable. Know the formula is going to be actual hours times actual rates and minus actual hours times the standard rate that we're trying to figure out. Actual hours is 10,850. Actual rate is $32. Okay, let's see if this works. Okay, and that minus that is, okay, so that means that this is higher. 355, yeah, that looks right. 355, 337.50. Divide that by 10,850. 3275. That's it, right, Drew? All right, so that worked. Took longer than your method, but it does work. Okay, and then B is confusing?
Yeah.
Okay, so actually it shouldn't be. The direct labor time variance, that's that is going to be this. It's going to be actual quantity times the standard rate minus the standard quantity, which is 11,000, which is standard hours, times the standard rate. I think the lesson here is I really need to stick to these tables because when I try to solve these without them, yeah, 360, 250. What's that? Yeah, it works. Yes, 4,912.50. Okay. Yeah, my brain just can't handle it. It's kind of like trying to convert from daylight savings into standard time. For some reason, my brain just freezes. Okay, we are done. Thank you for the moral support there, gentlemen. We'll see you later.